In this example, we're being asked to calculate the flux of this vector field. Remember, at each point, it just gives us a different arrow out of the solid that's actually sitting behind this plane. That is a tetrahedron. Now, they're not just asking us for the flux out the front. That would actually be harder. What we want to do is use the conclusion of the divergence theorem that says if you are trying to calculate flux through a surface. Now, mind you, if we didn't use the divergence theorem, remember this has four sides, and we'd actually have to calculate the divergence, the flux out of each side, and then add them together. Or if you have a closed bounded surface, which this is, you can do a triple integral instead, and that we're supposed to calculate the divergence of f, and that will be the integrand. This is usually dx, dy, dz in some order. I'm just writing them dx, dy, dz. So we have to calculate the divergence first in order to do this. I'm just using this notation because when we do the next, our last great theorem, we're going to see this del operator all over the place, and I want to be in the habit of writing it out. So remember, this is f1, f2, f3, like that. And I didn't have to write all that out, I guess. So here we go. Here's the del operator, partial x, partial with respect to y, partial with respect to z, and now I just put in f1, which is 2x minus y squared, f2, which is 4xz minus 2y, and then f3, which is xy cubed, like this. And so what are we going to get here? We're going to get the partial derivative with respect to x of 2x, that's 2, and this is dot product, so we put a plus. And then I want the partial derivative with respect to y of 4xz minus 2y, well that's minus 2. And then I want the partial derivative with respect to z of xy cubed, why that's just 0, and I get 0 like that. And what's that going to tell us? That's going to tell us this is a really easy integral to calculate because we're just integrating 0, dx, dy, dz, and that's just 0. By the way, we did get actually one more little piece of information. We see that the divergence at every point was 0. Not the overall flux out was 0, but that every point, no matter how small a sphere or cube we put around it, nothing's coming out. And that's it.